morning everyone, hope you're all safe with a good health. With you Ms. Dina Al-Badri, science teacher for grade 8. Today we'll start Unit 2, Lesson 1, Sound, Wave and Hearing. What is the sound? We said that the sound is produced from the vibration of the body. So the sound of vibration is complete back and forth motion of an object. Beating a drum causes the drum skin to vibrate, which causes the air around it to vibrate. Okay. A sound wave, we said that we have two types of wave, longitudinal wave and transverse wave. So the sound wave is a longitudinal wave that is caused by vibration and travel through a medium. So the sound wave need a medium, not like the light. Light can move inside, don't need a medium to travel. But the sound wave is a longitudinal wave which need a medium to travel. In a longitudinal wave, the particle of the medium vibrate in the same direction that the wave travel. As the wave passes through a medium, its particle compress together and then spread out. Longitudinal waves are also called compression wave. They are made up of compressions and rarefaction. A compression is a part of the longitudinal wave where particles are close together. So compression is a part of the longitudinal wave where the particles are close together. But rarefaction is a part of the longitudinal wave where particles are spread apart. How does the sound wave travel? Sound waves travel in all directions, away from their sources. They can only travel through a medium. All matter, solid, liquid, and gases, is composed of the particle. The particles in the matter make up of the medium through which the wave can travel in it. So, sound wave can't travel in a vacuum. The particle of the medium only vibrate back and forth along the path of the sound wave. Most sounds travel through the air, but some travel through other material, such as water, glass, and metal. In a vacuum, there are no particles to vibrate, so no sound can be made. Sound must travel through the medium to be detected. Okay, how do humans hear sound? Humans detect sound with their ears, which act like funnels for sound wave. The ear directs sound vibration from the environment. The ear directs sound vibration from the environment to the three tiny bones in the middle ears. These bones carry vibration from the eardrum to the oval window, which leads to the inner ear. Vibration travels through the fluid to the cochlea, which has thousands of nerve cells. Each nerve cell has tiny surface hairs that bend with the vibration to send electrical signals to the brain, which interprets the signal as a sound. So, in this video, you are going to see what happens in your ears to send the signal of the sound to the brain. Okay, watch carefully.
Have you ever wondered how sounds make their way from the source all the way to your brain? Take a trumpet, for instance. When it's played, it makes sound waves in the air. The outer ear catches the waves, which then travel through a narrow passageway called the ear canal. The sound waves reach the eardrum, which is a membrane roughly half the size of a dime. They make the eardrum vibrate, which in turn vibrates three tiny bones called the malleus, incus, and stapes. These bones amplify or increase the sound vibrations and send them to the cochlea. The cochlea is shaped like a snail and is the size of a garden pea. It is filled with fluid, and the sound vibrations make this fluid ripple, which creates waves. Hair-like structures called stereocilia sit on top of hair cells and are grouped together as hair cell bundles inside the cochlea. The hair cells inside the cochlea ride these waves, and the hair bundles are moved. The hair bundle on top of the hair cell turns these movements into electrical signals. As the hair bundles are moved, ions rush into the top of the hair cells, causing the release of chemicals at the bottom of the hair cells. The chemicals bind to the auditory nerve cells and create an electrical signal, which travels along the auditory nerve to the brain. Different hair cells respond to different frequencies of sound. The hair cells at the base of the cochlea detect higher-pitched sounds, such as a piccolo or flute. The hair cells toward the top of the spiral detect progressively lower-pitched sounds, such as a trumpet or trombone. At the very top or apex of the spiral, the hair cells detect the lowest-pitched sounds, such as a tuba. The auditory nerve carries the electrical signal to the brain, which interprets the messages as sounds that we recognize and understand.
Okay, that's all. Hope you all understand. Next time, inshallah, we will complete our list. Goodbye.